The same applies for electrical charges. So just to show you the connection here, the electric potential energy can be calculated using the charge, Q, times the strength of the electric field, E, times the distance through which it was moved. Do not be concerned with that equation. We're not going to look at the mathematics in this video. I just want to be clear that I used the same electric field, and that's how I acquired these three values. So just understand that these three values are the actual calculated values that we would obtain based on my assumptions. That's easy enough and simple enough for us to move forward. So assuming that I measure the energy that these three charges had, 2 meters from the negative plate, I'm going to find that A has 400, B has 1600, and C has 2400. I can do the same thing I did in the previous example, and I can divide each of these by the amount of charge that they possess. And once again, I'll find that anywhere along that line, I get the same rate at which energy is gained. In this case, 200 joules per coulomb. Now, a joule per coulomb has a very special name, which I am sure you've heard before, you just likely didn't realize it. A joule per coulomb is also known as a volt, and that's what voltage is. Voltage is really measuring the rate at which an electron gets energy as it passes through different points. So a 200 joule per coulomb potential is simply stated a 200 volt region. If we remove those charges, we can now say that anything located at this location, which is 2 meters above the bottom plate, the negative plate, has a potential of 200 volts. Whether I place a charge there or not, that is the potential at that point. Charges will gain 200 joules per coulomb that I place at that location. Why is this helpful? Because without having to do any advanced mathematics, I know that if I place a positive 4 coulomb charge there, well, for every 1 coulomb, it gets 200 joules. So for 4 of them, it gets 800 joules. I immediately know that that will gain 800 joules of potential energy. If I place a positive 10 coulomb charge at that same location, it still gets 200 per 200 per coulomb. So it ends with 2,000 joules of electric potential energy. It doesn't matter how much energy they have. At the locations that they are located, it is a 200 volt potential. Property of the field, the potential. The energy is possessed by the charges in this case. So please, 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 and I've said this 1,000 times, the energy is a property of the charge. The voltage is a property of the field. If I remove the charges, the energy is gone. If I remove the charges, the potential, the voltage is still there. The field itself has the potential, the voltage, and the charges themselves acquire energy when they show up in those locations.